Hi there. Today we're going to be starting chapter 14. And chapter 14 is all about probability, but before we get to that, let's take a minute to review the fundamental counting principle and also some of the things that we can have on our calculators, okay? So the fundamental, so we will need graphing calculators for this. So I'll let you guys get those out. I'll pause it real quick. So we're going to be starting with the idea of the fundamental counting principle. We'll start with two events. If one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is going to be m times n. Okay, so let's say that we have a basketball team that they have various shirts and shorts that they can wear for their weekly game. Their shirt colors include red, white, and silver, while their shorts are available in blue, black, heather gray, and forest green. How many different uniforms can the team select from to wear for this week's game? Well, we have two things we're looking at, shirts and shorts. How many different shirt options do we have? 1, 2, 3. How many different short options do we have? 1, 2, 3, 4. So all we do is multiply 3 times 4. So we have 12 different options. That's the fundamental counting principle. So what about for 3 or more events? Okay, this can be extended to 3 or more events. So for example, if 3 events can occur in m, n, and p ways, then the number of ways that all 3 events can occur is m times m, n times p, and so on. If there are other events, you just keep multiplying those out, okay? So a sporting goods store who specializes in custom designing for bikes has a variety of choices for its customers. They can select from 3 different kinds of bikes, including BMX, racing, or mountain. Additionally, customers have the option of 3 different wheel sizes, 20, 22, or 24 inches, 2 wheel colors, white and black, 2 seat sizes, and 5 bike colors. How many bike choices does the store offer? Well, let's look at all the different kinds of options that they have, okay? First of all, we have the kind of bike, and then we have the wheel size that's mentioned. Then we have the wheel color that's mentioned. Then we have the seat size that's mentioned. And then they have bike colors that are mentioned. Okay, so let's look at how many each of those have. So we said that they had 3 different kinds of bikes, 3 different wheel sizes, 2 wheel colors, 2 seat sizes, and 5 bike colors. So then we would just multiply all of those things together. We would just take 3 times 3 times 2 times 2 times 5, and that gives us 180. So that's all we do for the fundamental counting principle, okay? So because this is a pretty easy idea, let's also talk about the idea of a factorial. The factorial is something you can only take of a positive integer. And what a factorial is the factorial is the product of that integer n and all of the positive integers below it. So for example, so that's what the exclamation point is, okay? So the exclamation point really means factorial. It's not that someone's super excited about the number 6, okay? What the 6 is read is not 6 exclamation point, but it's read 6 factorial, and it's equivalent to 6 times 5 times 4 times 3 times 2 times 1, and then we stop at 1. Because if we went to 0, they'd all be 0. So what we multiply down all the way to 1. Okay, and we can find that by taking 6 times 5 times 4 times 3 times 2 times 1, and that gives me 720. Now, that's a lot of typing, isn't it? So I'm going to show you how to do that on the calculator, okay? But before we do that, let me just tell you by definition what 0 factorial is. The factorial of a positive integer is where we go all the way down to 1, but notice 0 is not a positive integer, and we don't take the factorial of negative integers. But because of some formulas that exist, we have to have a value for 0 factorial, and just by definition, 0 factorial is going to be equal to 1, okay? So anytime we see 0 factorial, we can replace that with 1. Now, let me tell you how to get to factorial on the graphing calculator. What we can do is we can go to the math button. We're going to be using that a lot in this chapter. And this time we're going to arrow over to PRB. And we're going to choose number 4. So let's practice doing 6 factorial in our calculator with this method, okay? We're going to hit the number 6. And then we're going to hit the math button, arrow over to PRB or prob if you have the new operating system. And then notice number 4 has the factorial symbol. And then that gives us that 720, just like we got when we multiplied it out, okay? So that's going to be much more efficient for something like example 2a, where they're asking us to find 30 factorial. So if I want to find 30 factorial, I'm just going to hit 30 and then math, arrow over to PRB or prob, hit number 4 so that 30 factorial is in my screen and press enter. Now you might be concerned because we see this 2.6 and like, how are we getting a decimal? And I want to call your attention to this E32. This is the calculator's way of telling us that this is scientific notation, okay? So one little note here that the E, a capital E in the calc, really means scientific notation. And scientific notation always means that that's going to be something like times 10 to some sort of power. So the fact that we have this here means that we have this value times 10 to the 32nd power, which would mean that I would need to move this decimal over to the right 32 times. And that's the purpose of scientific notation. It helps us avoid the zeros, okay? So let's just take it to maybe 3 decimal places. So 2.653. And then the E32 means that I'm going to multiply that by 10 to the 32nd power, okay? And I'm putting approximately equal because, again, like it's actually not even close when we think about the magnitude of this number and about how we rounded to like this crazy spot that's a very large value. But that's what we'll do when we end up getting things in scientific notation. We'll just write it like that, okay? Let's talk about doing 120 factorial over 118 factorial. If I enter this in the calculator, 120 factorial divided by 118 factorial, I notice that I get an error. It's an overflow. The reason is that this 120 factorial is so big that like the calculator can't even handle it, okay? So notice that here we had an overflow. That doesn't mean you can't do it. What that means is that we're going to write this out as far as what it means. So let's think about what we said. We said 6 factorial is 6 times 5, blah, 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 right? So doesn't that mean that 120 factorial is 120 times 119 times 118 times 117, okay, etc.? Okay, I'm not going to make you write all of them out. But let's just remember that's what 120 factorial means. Let's write the same thing for 118 factorial. That means that we're going to have 118 and then start going down. Okay. And again, it does keep on going. But notice that when we look at these different pieces, we have these common factors. And remember, you can cancel factors that are common in your numerator and denominator. And you see that once we start with 118, all of these end up canceling out. So 116 will cancel, 115 will cancel, 114, all the way down to 1. So essentially, everything cancels out except for 120 and 119. So then to get this answer, we can just multiply 120 times 119. Oops, I don't know why I pressed enter twice. And we get 14,280. Okay, so just if you do get an overflow in your calculator, just make sure to think about what factorial means, write it out, and I bet that would help. Okay, so let's kind of put it into context here. Example 3. A baseball coach has a total of 9 players and needs to come up with a batting order for their upcoming game. How many batting orders are possible for the coach to create? Well, it looks like in this question that they're going to have, that they need all 9 people that are going to be there, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different slots. And there are 9 players that are going to fill those slots. Well, how many possibilities does the coach have for the first player? Well, they could pick any one of the 9. Okay. Now, what about for the second player to bat? Well, we don't have 9 options anymore because 1 has already batted. So because 1 has already batted, that means that I only have 8 left. And then after that, 2 have already batted, so I have 7 left. And hopefully you guys see the pattern that's going to be happening throughout. The coach keeps running out of people until the last 9th player is the only option he has to bat last. And due to the fundamental counting principle, that means that we're going to be multiplying all of these things together. Now, before we start punching things on our calculator, does this look like anything that we've just talked about? Notice that we have 9 and we're multiplying integers all the way down to 1. So instead of typing all of that in the calculator, why don't we put 9 factorial in our calculator? So I'm going to take 9 factorial, and I see that that's 362,880. So that's how many possible batting orders that coach could make. That's a ton. Now let's say the coach is like, I'm overwhelmed. The coach is deciding that he wants the pitcher to bat last and the catcher has to bat first. Okay, so he still has 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. But this time he's making the pitcher bat last and the catcher bat first. Okay, and again, I know you guys are not going to want to write the little lines out, but especially because this is the first part of the lesson, just please take my advice and humor me, okay? So let's just start by filling in these special positions, the catcher and the pitcher. Well, there's only one catcher, so he has to go here, and only one pitcher, and he has to go here. So that means that all of these are the other players. So we take out the catcher and pitcher. How many other players are left to choose from? 7. So there are 7 different people that could bat here. And then this guy can't bat. The catcher and pitcher can't bat. So then we have 6. And then 5, 4, 3, 2, and 1 again. Using the fundamental counting principle, we'll multiply each of these together. And notice that these ones are kind of arbitrary in multiplication, but I do have this part here that this is really 1 times 7 factorial times 1, which is really just 7 factorial because 1 don't affect multiplication. And so I could find what 7 factorial is. And I see that that gives me, 5,040. So if he makes the catcher bat first and the pitcher bat last, then he's down to 5,040 possibilities. That's a little bit better. But now what about letter C? he wants to try something else. This coach wants to try all of the outfielders batting first and all the infielders batting last. In case we don't know anything about baseball, I'm telling you, there are 3 outfielders and 6 infielders. So we still have 1, 2, 3, 4, 5, 6, 7, 8, 9 positions. But these 3 have to be outfield, and these 6 have to be infield. So let's just look at this piece by piece. Outfield. How many players are there to choose from? 3. So he has 3 options, and then 2, and then 1. Now let's focus on the infield. At the beginning, he has 6 options. And then after that, one bats 5, 4, 3, 2, 1. Again, by the fundamental counting principle, we'll multiply all of those together. And maybe you notice that the outfield could be represented as 3 factorial, and the infield could be represented as 6 factorial. And you should be able to put it in your calculator just like that if you'd like. You can take 3 factorial and then right next to it 6 factorial. You could put a time sign between them if you wanted. And then that gives us 4,320 different possibilities. So less possible batting orders, but still something good to deal with there. Okay. So the next questions are the you try questions. And I will show you what my answers look like for those in just a second, but I suggest that you pause the video and then you try the your turn questions on your own and then see what the answers look like. Okay, so go ahead and pause and try these 4 your turn questions on the back. Okay, I wanted to make sure to at least talk through these because I know that in number 1 in particular, a lot of students sometimes struggle on your turn number 1. Remember, think about each slot. There are 4 nights. The first night, second night, third night, and fourth night. The first night, you have 16 games. The second night, you have 16 games. The third night, you have 8 games. The fourth night, you have 8 games. That's what you want to multiply by for that your turn, okay? We get 16,384, okay? For some reason, people struggle with that one. They try to multiply different pieces together. But again, putting those slots there to see what I'm multiplying together really does help me. Number 2, we have 8 teams competing in the National Air Hockey Tournament. And in this situation, we have 8 different, so all 8 teams will finish. So this is really equivalent to 8 factorial, which is 40,320. Now let's say a team was disqualified. So this is the disqualified team over here. So that means that there are only 7 others. So then, and that ends up being equivalent to 7 factorial, which is 5,040. In number 3, we have 8 factorial over 0 factorial. Instead of entering all of that in the calculator, I'm going to use the fact that 0 factorial is equal to 1. And then anything divided by 1 is itself. And I'm just going to enter 8 factorial in the calculator and get 40,320. Then in number 3b, I think about what 85 factorial means and what 84 factorial means. And everything cancels except for the 85. So that's just my answer is 85. And then the last one, number 4, 4 individuals can run. How many ways can the men on one team run in the competition? Well, I mean, if you're labeling these, again, this is just who's going first, second, third, and fourth. So we have 4 options, and then obviously only 3, then 2, then 1. So 4 factorial, which is 24. And so that's the idea of the fundamental counting principle, okay? Hope that was easy for you. You guys have a great day.